Welcome back, ladies and gentlemen. We're moving on to day 2 of graphing sine and cosine. We're going to be graphing these things by hand. I know we did a little of that in the last lesson, but we're going to get a little more advanced with it now. Okay, just recall our general rules for sine and cosine. If I'm graphing one of the kind of generic formulas for those, our amplitude is always the absolute value of A. Remember, amplitude is a distance, so don't include any negative part of that variable. Our period is going to be 2 pi over b. Remember, it's normally going to be 2 pi, and then just divide by whatever your b is. Our horizontal shift is c over b. And a vertical shift is just d. There's a homework down there. Nothing to write here, but let's go. Alright, before we start graphing, I want to talk about amplitude, period shifts, and reflections for something like f of x equals 2 minus 5 sine 3x plus pi. Okay, now this equation might be written in kind of a weird form from your point of view, but the book does have its reasons for doing it every now and then. But anyway, here we go. Couple things. This 2, notice how this 2 is kind of our constant term being added or subtracted. Normally you'd think about being added at the end, but every now and then we put it in the front. And so what you do need to recognize is that is still a vertical shift here. Okay, the other thing is, depending on your personal opinion, if you like the c over b as far as your shift, then leave it in this form. If you want to be looking at this thing and see the exact shift staring in the face, then we're going to do a little factoring right here. So I'm going to rewrite this thing, and you may or may not want to do this. And there's really 2 changes, and if you like one and not the other, then do whatever you like best. But here we go. Okay, I'm going to put the 2 at the end, so I'm going to start with a minus 5 first. And then I've got my sine, and then here's where that factoring comes into play. So I personally like this. I like to factor out the 3. So whatever coefficient I have, whatever my b value is, that means I'm going to factor it out and just leave myself with an x plus. Okay, now here's the goofy part. If I'm taking a 3 away from pi by factoring, I'm basically dividing, so that becomes pi over 3. Again, think of distributing it back through and make sure you get what you started with. Okay, so I get a very, very messy angle measure here. Remember, this thing after the sine is actually the angle measure. Okay, and then finally the 2 comes to the side. Okay, so the 2 things you may or may not want to do is move the 2 to the end and factor out the 3. So you decide which of those you like and which ones you don't, and do whichever ones you like. Okay, so anyway, now the amplitude of this guy, remember, is your absolute value of A. So absolute value of negative 5, of course, is positive 5. Okay, our period is always 2 pi over whatever our b value is. In this case, our b value is this guy right here, so it's the 3. And that one doesn't reduce or anything, so I'll leave it alone. Okay, sometimes depending on the number, of course, you might be able to reduce or change that around in some way. Okay, any reflections? Okay, basically any negative signs multiplied are going to be our reflections. So I've got one right here in front. I don't have one on the inside here by the x, which would be the only other possible way to have it. And so this reflection by the negative out in front is a reflection over the x-axis. Okay, of course, logically that means that the negative inside here, either on the 3 or on the x, would mean you're reflecting over the y. Alright, any sort of shifts going on? Well, I've got 2 shifts. I've got something going on inside, so that affects us horizontally, and something outside is vertical. So my inside with the x, okay, it's horizontal, and remember he's lying to you. So though it's a plus, I'm really going left pi over 3 here for a shift. And then the other shift is the plus 2, telling you the truth, so then I'm going up 2. And there's all the possible things that could pretty much happen for one of these graphs. Alright, so here's my basic set of steps for graphing sine and cosine by hand, and we're going to graph 2 full periods. I don't say it here, but we're going to do one kind of on the positive side and one on kind of the negative side. But here we go. Okay, we're going to determine the amplitude, period shifts, and reflections. Then we're going to draw a midline based on any vertical shifts that we have. We're going to draw max and min lines based on the amplitude. Find a starting point, which is kind of vague right now, but hopefully makes sense as we do it, based on the horizontal shift. We're then going to mark off quarter periods on the x-axis, and again, hopefully that'll make more sense as we do it. Then we're going to plot max, min, and middle points of 2 periods, paying attention to reflections because that will throw you off if you don't. And then we're basically going to connect the dots by drawing a smooth curve. Okay, and again, that doesn't make a whole lot of sense now probably, but after we do a couple, then hopefully it will. So here we go. Alright, our first example is going to be y equals negative 3 plus sine of x over 2. Alright. Now, that negative 3 being in front, again, this is something the book is going to do on occasion, but really, if you think about what's going on here, I've got, rewriting it now, sine of x over 2 minus 3. Okay, now, I suppose they put the minus 3 in front sometimes because if I'm looking at this, maybe I think that that minus 3 is part of the whole angle measure going on here. So I think that's why they put it in front, but I think in a case like this, whether or not you're just plain old used to it, you can recognize that, or you just put parentheses around there, I think it makes it more obvious that that -3 is actually a vertical shift of some sort and not going to be a horizontal shift because it's not really lumped in with the angle. Okay, but whatever works for you is fine with me. Okay, so let's get to the stuff that we need to do to graph this. Okay, now amplitude, again, there's no number in front, so my amplitude is basically a 1. Okay, now the period is going to be 2 pi divided by my b. Now notice the b, since I have x over 2, that's like having 1/2 x. So my b is a 1/2, and then dividing by 1/2 is the same thing as multiplying by 2. So that really gives me a period of 4 pi. Okay, now in those previous steps I mentioned quarter periods, and that's going to be a big aid in graphing, which basically means now I'm going to take 4 pi divided by 4 and give me pi. So that's basically going to be the distance between each center to top, or top to middle, or middle to bottom point as I do the graph. Hopefully it'll make more sense as I actually do the graph. Okay, anyway, shifts. Okay, now, again, I don't have any horizontal shifts because there's no adding and subtracting inside the parentheses here, but I do have a vertical shift. So my vertical shift is down 3, and then finally reflections. Okay, I don't have any negative signs in the appropriate place to cause reflections, so that's none. Alright, now let's start putting stuff on the graph. Okay, first thing I want to do is get my midline set. And again, the midline is normally right along the x-axis, but any sort of vertical shift is going to change that. So in this case, I'm going to shift down 3. I caution you though right now, the amplitude is going to kind of help dictate to me at least how far my tick marks are going to go apart. Because I need to go down 3, but then that's the center. I need to be able to go the amplitude distance both up and down from there. So basically, I'm going to go down 3 for my midline, but then my amplitude is going to take me 1 more in that direction, so I need to make sure I have space enough for 4 tick marks down here. So 1, 2, 3, 4, there we go. Okay, I don't really need much going up. I can put a couple there if I feel like it, but really nothing much going on there. Okay, so at this point I've got my down 3. I'm going to make a horizontal line, or at least as close to horizontal as I can, to be my midline. Okay, and then again, up and down 1 for my amplitude is going to give me how high and how low this graph is going to go as it kind of bounces through its wave pattern through the graph. So, boom, and boom. Okay, hopefully that's reasonably straight. Okay, now I'm going to get my starting point, and it's going to be based off the horizontal shifts, although you also have to recognize where you are. Okay, now again, sine normally starts in the middle and then goes up from there and then continues on its path. So basically, it starts in the midline. So right now I'm starting at the -3 down here, and there was no horizontal shift, so basically I remain right here on the y-axis at -3. Okay, now what I need to do is determine how far I have to go before I hit my top, middle, bottom, etc. points, and that's again where this quarter period is going to come into play. Okay, so my pi is my distance. So basically what I'm going to do is from my starting point here, I'm going to count off the appropriate number of tick marks, and again I'm going to go 1 period this way, and I'm breaking that period into 4 chunks. So I'm going to have pi right here. That's going to be then 2 pi, because I'm going 1 more pi, 3 pi, 4 pi, and there you go. That's going to give me 1 period to the right. If I want to go 1 period to the left, I'm going to try to put these tick marks reasonably well spaced, like the last ones were. And then basically I'm just going in the negative direction, so that's going to give negative pi, negative 2 pi, etc. Okay, so really there's all my framework, and now from here I can finally start plotting a little more of the graph. Because right now I've done a lot of work, but I only have 1 dot. Okay, again I have to remember the pattern for sine starts by going up. There was no reflection, so I'm not flipped over and going down in this case, so I am going up to start with. So here's basically my top point here. I come back down to the middle. Okay, sine continues by heading back to the bottom, and then back to the middle as it kind of bounces through. Okay, kind of continue that pattern back in the other direction, sends me down as I go to the left, then to the middle, up to the top, and then back to the middle here. Okay, and now all those dots, again I'm trying not to draw a big tooth pattern, so it's all jagged tooth. I should be drawing some kind of a curve pattern. And if you miss a dot like I just did right there, don't have a heart attack. And there we go. Okay, now granted I could put arrows on the ends of it, but the directions we're going to work with are saying just graph 2 full periods, so once you got that, I'm not going to be picky about whether or not you put arrows on the end of this thing. But anyway, there's what that graph should look like and how it all comes together. Alright, our next example is y equals -2 cosine of 4x plus pi. Here's another one that you might want to rewrite based on your personal preference. We've got negative 2 now cosine, and the reason you might want to rewrite is that 4 right there, because this is going to have an effect on our shift that is present. So in case you like to, you factor out the 4, leaves you with x plus pi over 4. Okay, again, think of redistributing, make sure you get back to what you started with. And there you go. And again, the only reason to do that is so that the shift is now staring you in the face instead of you having to divide those two numbers. So again, personal preference, but here we go. Amplitude, absolute value of negative 2 is 2 period 2 pi divided by your b, which is 4, and that reduces nicely to pi over 2. Okay, which then takes me to a quarter period, dividing this by 4 again. 4 in this case because of the quarter period, not because of the 4 that was right there. Pi over 2 divided by 4 is going to give me pi over 8. And pi over 8 is my little chunks as I move horizontally away from my starting point. Okay, my shifts, I don't have any vertical this time, but I certainly have a shift horizontal. In this case, it's going to be left pi over 4. Okay, remember, he's lying to you. And then our reflection, we do have a reflection, and it's going to be over the x-axis. Okay, so there's our relevant information. Okay, so again, first of all, I want my midline. Now, I'm going to start drawing this midline in, but you might be like, well, I already got the x-axis. Do I need to do that? And the answer is no. If you don't want to draw in a secondary midline right over the top of an x-axis, then I won't falter for that. Moving on to my amplitude of 2. So I need at least 2 tick marks each way. I'm just going to give 3 just because I feel like it. Of course, anything up to 2 is fine. Okay. Okay, so there's the top and bottom. Again, my graph is simply going to bounce between the two as he goes, but let's go. Okay, now I got to figure out my starting point. Now this is going to be based on, again, the horizontal shift. Okay, so normally I'd be starting right on the y-axis, but now I need to kind of go, in this case, left pi over 4. And now another thing I want to do before I get too crazy about this is realize that my quarter periods are pi over 8. Okay, so notice pi over 8 is half of pi over 4, so I'm going to go about right here. Okay, and as you do this more, you get a little more used to it, but if I call this negative pi over 4, and I start thinking of adding pi over 8s to this, my first pi over 8 this way is going to be negative pi over 8, and then my next one's going to be right at the origin. Now I kind of recommend putting some kind of a mark there, just in case that isn't actually a quarter period mark. This helps you remind you that it is. Okay, I'm going to go another step this way. Now it takes me to positive pi over 8. And then one more step this way takes me to positive pi over 4. Okay, now notice that's 4 chunks, so that's 1 period to the right now. So I need to go a period to the left. Okay, subtracting a pi over 8 is going to give me basically, this is negative 1 pi over 8, negative 2 pi over 8, and then this is negative 3 pi over 8. Okay, one more step gets me to negative 4 pi over 8, but that reduces to negative pi over 2. Okay, one more step gives me to negative 5 pi over 8, which doesn't reduce. Okay, and at this point I've got 1, 2, 3 steps, so I need one more. Negative 6 pi over 8 reduces to negative 3 pi over 4. Okay, if you're not good with fractions, I don't know what to tell you. Practice and get better. Okay, so anyway, my starting point, which I could have done earlier, but I guess I didn't, so let's do it now. Okay, again, normally cosine will start at the top of its curve. Okay, but, again, we're reflected over the x-axis, so instead of starting at the top, I'm going to start at the bottom. Okay, and then I've got my quarter periods all laid out. Again, basically I just kind of move one line at a time, bouncing up and down as I do this. So, starting at the bottom now, my first takes me to the middle, then I go to the top, then I go back to the middle, and then to the bottom. Okay, notice this coincidentally ended up right there at the y-axis to the top, but that won't happen every time, I promise. Okay, going back to the left, I bounce up to the middle, to the top, back to the middle, down to the bottom. Okay, and again, once I've got all those dots, I just want to draw my nice smooth curve in there. And again, try to hit at least one of the points as I do this. Wow, that was bad, but hopefully you get the point. And there you go. There's 2 full periods of your cosine graph. I'd like to do just one more now because of something that hasn't happened yet that could, that I don't want you to freak out if it does, and basically when it does. But here we go. Y equals 1/2 sine of pi x plus 1. Okay, now one thing about this is it's got a pi in there, so that's the thing that I hope you don't freak out about. The other thing is that this is plus 1 here. Now notice there are no parentheses. So if it helps you, draw in the parentheses around just that to kind of help indicate to yourself that this 1 is completely outside of the angle and not a part of it like the pi and the x are. Okay, once we got that settled, we can go ahead and start talking amplitude and all that other stuff. So amplitude's 1/2. Now here's the funny thing. My period is going to be 2 pi divided by the b. Now notice in this case, b is pi. So my period is 2. So what's really nice about these graphs is if you want a graph that kind of bounces around on some kind of a nice non-pi-ish number, which is what the real world mostly works on, you can have a graph, an equation, that has a pi in there, and then kind of gives you nice normal numbers. Okay, so anyway, 2 is my period, but if I'm taking a quarter of 2 is 1/2. Alright, then my shifts, I'm going to go up 1 in this case because of the plus 1, and the reflection, well, there's none in this particular graph. Okay, so my amplitude's 1/2, but again, what I want to do first is take a click of my midline, and the shift is up 1, but again, since my amplitude's 1/2, I want that first shift up 1 to be kind of a large value. Okay, the other thing is I'm going to put this 1 here, and have my center line going, and I want to do this far enough away that it doesn't look like a negative sign on the 1, because then that would blow people's minds. Alright, the amplitude is now 1/2, so now I want to put tick marks here and here, and again, depending on your own personal whatever, if you want to label those as 1 1/2 and 1/2 or something like that, then hey, go for it if it helps you work with this a little better. Okay, but anyway, there's my max and min line, so now notice my entire graph is happening above the x-axis. Okay, there we go. Now again, starting point, again, sine is normally going to start in the middle. There were no reflections or anything like that. There were no horizontal shifts, so he's still going to start right there in the middle. Okay, and then as far as my quarter periods go, my quarter periods are 1/2, so I'm going to count 1/2 at a time, so 1/2, 1, okay, either 1 1/2 or the 3/2, since I used a mixed number up here, I'll use the mixed number here. But again, no problem to me at all if you want to go with the 3/2 right there, or a 1.5. Alright, then again, okay, the nice thing about no horizontal shift is you can kind of mirror the left and right halves of the x-axis as far as your values. So negative 1 1/2 and then negative 2. Okay, now again I've got this, no reflection. If there was a reflection I would have started by going down, but in this case there wasn't, so I'm going to go up first, because that's what sine normally does. Back to the middle, back to the bottom, to the end. That's one whole period to the right, so let's go left now. Down, middle, up, middle, and there we go. And if I can hopefully hit a few of the dots this time, that'd be good. Almost got them all. Did I make it? Woohoo! Made it all. Alright, so anyway, there's the whole graph. And again, that's an easy way to get non-pi sort of numbers here, is by slipping a pi right in there, and gives you good numbers. But anyway, questions, comments, concerns, of course, ask me in class. I'll see you there.